Very good, McConnell, right?
Yes, sir.
Very good, your story.
Okay, thank you very much. Good evening. Shakur. Thank you very much for coming. And I would like to start by thanking my instructor, Mr. Shawan, and my friends, especially Sisai and the others, for supporting me all along. My name is Barihun Lokona. Actually, maybe I'm the one who came from probably a very distant background and then started data science. My background is in social sciences, most currently, social anthropology. So I have worked for many years in civil service, in research, in teaching. So this is my first time to try a new field, data science, probably after many years working in a different discipline. So overall, I have taken this data, probably the police report from local.gov, local government on Dallas City. So the data, I have tried several data. I have tried to deal with World Bank data. I found it in a way very difficult to manage that data within this short period of time. It's a little bit challenging, very interesting. I can give you more global perspective in many ways, all political, social, economic data on that. I have tried it, but I anticipated it will take me too much time to deal on those areas. So I looked for another data. I found this one. So this is a little bit manageable directly. I can do with that. But when we found it, I think the data has several problems. It was not well structured for one. There were several things missed. It was unorganized. Names have been, for instance, Dallas has been misspelled in several places. And it was also represented in different ways. Dallas as a city, Dallas, Texas, with a comma, without a comma, with a space, without space. So it was, you can see the same city represented in the data several ways. So that was one of the challenges in the data. So as you can imagine, it took several hours to clean up, to deal with it. So as a as a person who is dealing with data, the first time it was a little bit challenging, but with the help of my friends and Mr. Shaban, I was able to deal with it. General observation in terms of the data, in a way, the police arrest shows a predictable trend of increasing arrest starting, when you take the time, the time of arrest starts around the afternoon, around 3 p.m. and continuously increases until midnight, and it comes down, and at around 5 a.m. it stops until the next afternoon. So you can see a trend from the data, what time is the higher, the high point of arrest, what time is the low level, probably non-existent in some of the areas. I was, from the data you can see there are drug-related arrests. I anticipated it to be a lot. It was not that much, significant. It's a significant number, but compared to the data, which was close to 20,000 entries, it was about close to 1,100. It is small, but when you see it from a social point of view, it has also its own impact. It's significant from a social point of view, but from a numerical point of view, it's very small. As the trend shows in news reports and other discussions, the trend also shows a high number of African Americans are among those who have been arrested. So this is, I will mention it later. This is one of the issues we were trying to predict, who was going to be sort of to build a predictive model, but the data is already skewed. So if you do it on that, it's an obvious result. You can come up with an obvious type of prediction. So we dropped that one. There are also, most of the arrests is, U.S. people from Dallas, a large number from other cities outside of Texas. But a certain number, a significant number, are also foreign born. like a large number being from Mexico, then Honduras and other countries comes in. There are smaller number from the Middle East and other countries, but the foreign, born, it's not a large number when you see it. Again numerically, but percentage-wise. But it's such a significant number when you see that across the board.
Got a quick question. Where are those zip codes the highest under the rest?
740. Actually, this is close to where I live. I live in Richardson. This is in Dallas, where you have the border between Richardson, Garland, and Dallas.
Okay.
So this is one of the cities. 635 and 75 junction, the high as around the area.
Okay.
That area is that's the first one. This one is South Dallas, 16 and 17. Goes to the southern part of Dallas.
Okay.
So these are, I think, areas where we have some of the places. It also includes, I just mentioned some of them. 75231 also is part of it. But these are, with 3-4 digits of, numbers. I will show you,
Okay.
So Harold, how many times did you get arrested?
In terms of weeks, as you can anticipate, in a way, the Saturdays, the highest arrest in Saturday, then Friday, then Thursday. These are, when you are closer to the weekend, you have higher arrest. When it's during work day, people are sober, so you don't get much that type of activities. The other thing is that we will come back probably down then the data discussion. The large number of arrestees are homeless. So one of the ideas or the concepts we're going to predict was that with the arrest, in the business area, in the hotels or other premises on residential areas, but most of it is in open space like parking in the business area, parking in the residential area. So the parking in parks in the parks area, or recreation area, when they are arresting the parks area. So open spaces are common denominator here. So it's, and again the data becomes very much skewed. So it becomes obvious to deal on those types of stuff. So the first thing, as I explained in a way, I try to ingest the data to understand it myself before I started talking about it. So I try to, another story was that it has 78 columns, and then as we said, 19,600 something, 17 rows. So I have to reduce, it's a very large data, relatively, compared to what Martin said, the thousands of, close to 2 million rows, it is relatively small. But for me, it was large enough, so I have to reduce it and then select better features. So the first thing I started was eliminating column by column. I'm not gonna show you those parts. So later on, I came and then consulted Mr. Shaban, and he showed me a little bit handy way of reducing multiple columns at a time. And then we have also learned how to call a certain number of data, columns, before you even call the whole data to load on the Jupyter notebook. So that was in a way partly a learning process for me. As you see, these are the columns, as you see it, a lot of columns. So we have chosen this smaller number of columns. So we call the data. So we see some of the data is. So one of the things we did was that to show them later on the map, we converted, we introduced longitude and latitude into the data so that we can map those zip codes that we saw earlier, where are those zip codes are located across the city of Dallas. So this is a process of, we have called some of the libraries to help us to load the Latin long and also NumPys and other important libraries to do that. The other thing is that also there are also zip code confusions in several areas, so we have to also clean up that. Somewhere nonce empty columns, there was no report of zip codes, so we have to also fill in those empty spaces like as part of the imputation of the data. Those are, after we converted, these are the examples of the coordinates that we found through the process. So we try to combine addresses. For instance, arrest is local address, arrest is local city, arrest is local state, arrest is local zip code. This is local zip code, home zip code. This is where the person lives or where the person is arrested. So they have tried to categorize those information. The next thing I have tried to do was that to load I have to save in a way, as you know. If I leave it in a way as it is, and I don't save it, the next time I load it, I have to wait. The long wait that Martin has been talking. Hours actually. Some of the data on my laptop still, loading. So I have to also cross-check with Mr. Shaban to take some of the data to load it. So it takes so many hours. So I have saved it on my computer so that it will be easy to reload it in the first transformation. The data which is transformed from the raw data to a level that is readable and understandable. Then I load it here. So we started the imputation to see which area should be considered, which columns should be re-engineered probably to be better and usable in the process. Here I think I have mentioned, for instance, for Dallas City, you have Dallas unknown, DALLAS. You can see how disorganized the data was. So we have to clean up and create some sort of understandable or more manageable type of row. This is one column for one information, but you have it across the board. The homeless also, some are homeless, some is null. There is no. We assumed those people without home address, without zip code, those people are most likely to be homeless instead of people with IDs or some type of identification. So that was part of the data imputation process that we tried to categorize and create some sort of sense out of it. Home states is, as I said, most of the arrestees are residents of Texas. The large number is from Dallas, but there are also people from across the U.S. You can have it, Tennessee, Oklahoma, and you can call it Ohio. So those are some of the states are involved in the process. So we have to try to fill in some of the information. When it's necessary, we dropped some of the data so that we can have. But the other issue is that the drug types, you have processed marijuana, cultivated marijuana. For our consumption, in a way, marijuana will be a much more sensitive category than having a different level of marijuana details. The crack cocaine, powdered cocaine, that's also another area. So we categorize it together and created unorganized data. The other issue is that missing values, as I said earlier, as I mentioned earlier, for this one, either we have to drop it or we have to fill it with the information. That is the most likely area. So the first one was there were two unique values which were not much important for the data analysis. We dropped them. When I say we, I was also consulting, my mentor and teacher, Mr. Shava. So we try to make sense out of it. So we dropped that information. The other issue is that when there was a large number of data, about 219 of it. So if we drop it, it's really, affects the total number of data. What we did is that the large number, so this in terms of sex, in terms of gender. So what we did is that we took the actual categorized, the male, female type of gender, then we took the ratio and we distributed the 219 accordingly. A large number to the male one a certain number to the female one, so that we didn't skew the data. So we try to make it as balanced as possible. So this is how we did it in a way. We took, we split the major data. We get the percentage from that. Then we used that ratio to distribute the 219 missing values according to the percentage ratio. So we tried it. We checked it for the null value in terms of sex. Then it came up clean. So in terms of premises, I think it could be a repetition. This is the premise area. We wanted to consolidate the areas where the premises where the arrests were caught. So this is in a way parking lot, apartment, parking lot, park, condominium, townhouse, parks from different places, and we wanted to put them together. The same was single family residence, multiple residence, occupied, unoccupied. This also can be categorized in the same place. So this was in a way consolidating the columns and creating a meaningful category or feature. Consolidate the birthplace also. This was also across the board. So this is how we try to impute them. We try to give them values and make some sort of, as you see, a large number of it happen in Pennsylvania, Tennessee, Colorado, Oklahoma. You can see them across the cities. We try to, one of the missing probably, least probably, we could have put what you call the foreign born as a feature, but for our purpose, this worked for us. So we passed it and worked on this also. The other thing was that we categorized the data in terms of people who lived in Texas and people out of Texas, so that we have a binary type of two categories, because the large number is from Dallas. Next from Dallas, people out of Dallas, which is in Texas. So Texas could contain a large number of people. Then the rest of the US as another category. So accordingly, we did that. We came up with the two categories. We divided the data according to that value. So we take it back in a way. We have, as we said, we split the whole data into two. So we have to bring the two, the divided data together. So we can concatenate or merge the two categories together and create an integrated file, so that we can go on and review our data frame. The weapon, whether people were armed when they were arrested, this is also the data that we have. Majority of sorry. Okay, now as you see, still a couple of them are they have missing values according to we had been filling in the missing values for all the rows, so the columns. So one by one, we managed to fill in and then created and organized the data. So then the other thing I did was together with my instructor, to do some sort of exploratory data analysis. As we see, the null values, all the columns have equal rows, and the type of data that's there. So it was cleaned up and then became more manageable. So we did, some sort of visual representation. In terms of age, I haven't mentioned probably earlier, people between 16 and early 30s are among those who had been, been arrested across the board. The male is larger than the female, I said, but still the younger generation of girls are also high in number. So this is, but in terms of date, I mean, it includes from 2014 up to early 2016. So most of the data is from 14 and 15. In terms of birthplace, I mean, you can also see it in a way, non-Texas and Texas. I think because we have merged a large number of non-Texans together, you can see in a way how balanced it became. In terms of age, also, you know, drug-related and age-related and related, as you see. So yes, those people say they were arrested with drug-related issues were smaller in number, and those who were arrested without drug, are large in number. But the issue is that within the drug, there are people who has also prescription medicines in a way, which are reported as part of people who have been arrested with drug-related issues. In terms of premises, you can see in a way what type of premises they were in airport, business facilities, highway streets, motor vehicles, inside the motor vehicles, others, outdoor area, public, private, parking lot, personal services, recreation. All this, across the board, there have been, arrests. So that shows you how many.
Very good. Let's speed it up.
Okay. So we try to map it, the original map. This is a plot which shows you, the arrest areas in terms of plots where the arrest has been made.
You can show the other Jupyter notebook, the other notebook that's up. Is that starting too?
Yeah.
Is that the one with Shimon?
Yes. Okay, yes. Okay, these are also, in different, let's not to take, the time of others. I will show you the general, yeah. There are still, still we are trying to show, how the arrest has been distributed across. So here we try to see how, if we are able to see, some sort of different characteristics of the data. Doesn't show much of a difference, but that is, as part of the learning process, we're trying different methods, to depict what type of data, how the data reacts when we use different methods of representation. Here, I think in terms of time, you can see the high points are, this is depending on the arrest across time, You can see, a low level during the early morning up to 3 around afternoon. Then you can see the variations. Then it comes down and it goes up. So that's how time-wise how this has been shown on the data. Okay, I think the other map to show up. Yeah, this also shows how you can see how the arrest, it shows you different colors from which area has been let me magnify it a little bit.
I think the size is good. It's going to be just
Okay.
Yeah.
You can, when it's quiet, there is no arrest. The point shows how it becomes smaller.
It will go smaller.
It was smaller
because the map is cut off and not go down. Oh, that's okay. One more up. Yep. And yeah.
Yeah, there you go.
Okay. So it shows you, now it is quiet. When it started, it bubbles up, and the more bubble you see, the more arrest happens during that hours. You see now it starts to pop up and then it increases. So that goes parallel with the time frame that we have mentioned earlier.
So it's starting at about 3?
Yeah.
It starts about 3, then it increases until it reaches a peak at midnight. Then it starts to slow down, then it becomes quiet, then you have a quiet period, then it picks up again. So as I said, in general, this was made with the help of, I think I have to thank again my instructor, Mr. Shervan, and my friend Sisai, and the rest of you for helping him along the way. But this is a beginning for me, and then I have made a lot of efforts. I'm still in the process of learning, but I have seen a lot of good stuff. So this was it, and I thank you.
So Barihun, what's next for you?
As I said, I think I'm eager to learn again. Because I have seen some promising stuff. As I said, my background is a little bit in a different area, so I may take a little more time to gain more, I think, understanding and more working and more practice. And I'm looking at also sort of an opportunity to work on that. Work on more on this. I'm already, sometimes you need persuasion. I have been already, enough persuaded to work on the field, so I'm ready to work on that.
And what was your programming background when you started this whole thing? Zero?
Zero.
Yeah.
I have some computer stuff, not as a programmer, but I have some background in terms of using as a user, but not as a programmer. This is my first programming stuff. I'm still in the sort of in the middle area, but I think I have a hope with the help of my supporters here. I'm hoping that I will reach.
What development platform are you using? PyCharm or?
This one is Python and Pandas.
No, he's no IDE at all.
No? Oh.
Most of it is in the Jupyter notebook.
Oh, okay.
And there is Spider. I think they've used a little bit of Spider, which is an environment IDE that comes with Anaconda.
Oh, okay.
So you don't even need PyCharm. You just need Anaconda distribution, Spider environment, and you're good to go.
Okay.
Oh, okay.
Right.
And what about this interactive chart?
The interactive chart is done entirely in Carto.
Okay.
And the Carto has a way to upload your data as long as your data includes lat and long.
Okay.
So this is why Barihun spent a lot of time converting address into lat and long, right? You have to convert address and reverse engineer lat and long from address. There are a lot of addresses missing. That process of creating lat and long from address was the longest process. I think it took about a day of 20,000 rows of data.
Yes.
Back and forth, back and forth, back and forth, back and forth. Because it's free service, I think Google free service, it took almost a day. But once you have lat and long, you go to carto.com, upload your data, and it gives you options. And this particular chart is called a torque chart, T-O-R-Q-E, torque chart. Torque chart is based on time. So it says, what do you want to display based on time? And we say, we want to display where the arrest happened, and you give the categories in those colors. And if you see the bar there at the bottom, that's telling you by time.
Yeah.
It's actually a play. It's like a video recorder, right? It's playing by time. You can actually pause it and play it. And it's playing the number of arrests by time. And it's putting different categories by color. That's all it's doing. But those locations are based on lat and long, and you can see the flow. These kind of show up. Okay. Not a whole lot of work. Not a whole lot of work. Our work was primarily in converting address to lat and long. Once it was there, it was uploading to Carto and let Carto do all the magic. The biggest one was displaying this chart plot right in the Jupyter notebook. And you see the HTML tag right on the top. So that was displaying a plot right inside of Jupyter notebook. Okay. And I tell this, as a programmer, be as lazy as possible. Okay, let the platform do all the work for you. And if the platform is not doing the work, then you can customize. There's no need to start customizing when the platform can do all the work. So we took advantage of Carto. Right. Varihun, great job, my friend.
Thank you. Thank you.
Okay.
All right. Well, just to give you a brief introduction, my name is Mario Rojas, and I appreciate you guys being here tonight. I'm actually, as of today, I'm still a senior at UTD, and in a week and a half, I'll be graduating and walking the stage. So, it's a big accomplishment, and I'm really happy. Well, just to give you a brief introduction of my project, this project was part of a school project actually for my business analytics class. One of the requirements was to do it in R, but I decided to stick with my guns and go ahead and do it with Python. So here it is. The theme was oil in the gas industry, and it was about electrical submersible pumps. So if you guys don't know what they are, in the oil and gas industry, electric submersible pump systems are probably best known as the effective artificial lift method of pumping production fluids to the surface. In this case, oil. So here's just a picture of how one looks like, and don't ask me how this works, because I still haven't researched that. So
How does it work?
so if you're asking that question, there is a 1-minute video of how this EPS works. So here are all the components of the ESP system. There's the motor. This is in Brazilian, in Portuguese, so. Here's the electrical signals being sent to the sensor. See those little black little bubbles? There's a bunch of money signs coming up. So for those people asking questions, how it works, here's how it works. So what this sensor does, it brings back signals of how the motor is working. So from this component, the electric motor has a rotatable rotor that is contained in stationary stator. When the motor operates, the rotor rotates, causing rotary vibrations of the ESP assembly to occur. And one thing I do want to highlight that the vibration of this motor is really a key into predicting if this ESP is up or down. So for this project, I was asked to create a model that will predict when the sensor will be triggered up, down, or a warning message. So a failure of a ESP in a well can stop production or even lead to a dangerous event. So here are some variable descriptions of the whole data set. First one will be the well ID. The second one is the field. So there's 2 fields in this data set. One is called Singhorn and one is called West Swahi. And each field has their own blocks, running from A1 through D9. Each ESP has their own serial number. And all the ESPs have their own vendors, so there's 3 vendors in the data set. And there's a depth of the well and feed. Bean, I have no clue what that is. And the performance, that's the performance of the ESP system from low to high, and that's in one column. Here's the date of the unit that the unit was installed. Here's the volume or percentage of water. So the daily flow states how profitable the well is. The daily flow, the oil production in the barrel per day. So each ESP will have a number of tickets of orders generated for this device. And here's the average maintenance cost, average main cost monthly for that ESP. And here's what I want to predict. So the 3 status are running, warning, and down. There's a percent of time of ESP that the ESP is running. So, and the daily production variance is the difference between forecasted production volume and an actual production volume. Each ESP has their own region, and all ESPs are in the U.S. And each ESP has the time, so the time that it was recorded, and it's all in hours, minutes, and seconds. They all have the temperature intake and discharge pressure, the pump vibration rate and radial and axial, the motor temperature, the motor resistance, the motor current, and the leak voltage. Here's a side note that I put on for myself. I started researching more about this, and it seems that a pump vibration can really affect the status of a pump going down or up. So you're just importing my libraries and loading the data. This is a really good technique that I learned in Divergence Academy to use your notebook as a shell. Use shell commands on your Jupyter notebook to just see what you're uploading first. One thing I did notice that there's a bunch of dots in between the columns and that, so I decided to change that to underscores. So I changed all my column things with an underscore in between. And this whole data set has about 61,000, almost 62,000 rows and 26 columns. One thing I did want to recognize for pandas is to recognize the date that it was installed, so I changed that and parsed it with the date time format. I also did that with the time. So then I hit up the exploratory analysis. I wanted to see how many per ESP, how many were down. I mean, from per ESP, I wanted to check the status of how many times it triggered down, running, or warning. So I converted that into a single data frame so I can use it on Seaborn. And here's a nice graph that I saw on the Seaborn website, where you have all that gallery selections. I decided to use one and tailor it to my own, and just emphasize on how many on the top ESPs that trigger warning. Then I wanted to emphasize of how many ESPs trigger down, so how many times they trigger down throughout the day. Then I wanted just to see a total of putting them together with warning and down per ESP, and just showing you which one triggered the most bad signal. Then I wanted to dig a little deeper, so I decided to take the mean of the X variables and the mean of the Y variables and select all the rows. And I divided it into above the mean is high vibration and below the mean is low vibration. And I did see quite a lot of difference. I saw that the one with the high vibration had more warnings, more downs, and less running status, while the ones in low vibration had a bunch of running and quite a little bit of down and warning. So this is just to show you some other different ones I made. I wanted to see all this ones right here are the ones that are running. As you can see, you can already question yourself. Well, it seems like the ones they're investing a lot of money on the ones that are already running. So why making those big investments in there? We can just maybe replace it and use that money and allocate it to the ones that are actually triggering down and warning. As you can see, there's already about $77,500 being invested on the ones that are triggering down and a warning.
Maury, how did you generate this chart?
I generated this chart using R, so to satisfy my professor. I did this with R and I used ggplot.
Okay.
So with the data wrangling, I just wanted to check how many nulls I had in the data set. There was about 100 nulls in region and 200 nulls in TIC. So for this probably wouldn't make a big difference in my data, but I just decided to fill it up anyways, which I fill up all of them with US. And with the TIC, well, from this I noticed that all the columns had the same value from the top top row and the bottom row. So all I did was a forward fill method using pandas, and I fill all my nulls. The next step was just to check for outliers in the data set. So I decided to plug all the numeric values into one big graph here. And I did notice a lot of outliers here in the average maintenance cost, TIC, the PICA, all this columns here. And one thing I wanted to check, well, were this outliers part of the data set, or this outliers were an error in the data set? So I did notice that there were about 60 ESPs that trigger for each outlier, so I decided to classify them as part of the data and I decided to keep them there. For X and Y, for the X and Y variables, I did see a lot of outliers as well. I also looked into the data and about 100 ESPs trigger that X and Y variables. So I decided to keep that as part of the data set and leave it there. So these are my data transformations. I wanted to check the date installation and I wanted to count the date. The age of it. So with this programming, so I'm using some, what did I do here? Oh, this is definitely a code that I saw in Stack Overflow. So thank you, Stack Overflow. Let me try to expand this a little more.
Savannah, how does he make it bigger? Okay, he's got it. Yeah, that's better, thanks.
So I decided to add the age of that pump. Another variable I decided to use was the performance difference. Remember how I told you that one column was the whole performance? So I decided to turn that column into a string and just select the first four and the last four characters, and from there I decided to make the calculation and do the high minus the low. And then I decided to add dummies to the data frame, knowing that field were 2, and so field and vendor I decided to do dummies for them. One thing I didn't want to do dummies on the block because both fields had the same block, so I couldn't make any, and I couldn't see to which block it belonged to, which field it belonged to the block. And I decided to do the binary encoder for the labels. So I decided to do, my initial approach was to see, put 0 as down and warning, put 0 for warning and down, and 1 for running, and then down 0, and then have 0 for down, 1 for warning, and 2 for running, just to check the difference of the models that I'm about to create. So I decided to, with this column, just showing how to save it to this SVCSV to do analysis in R. So here's the fun part, the logistic regression model. So for my logistic regression model, I decided to put all these columns in my features. And I decided to use the one with the 2 labels, which is down 0, warning 0, and running is 1. I did my train test split. So one thing I did here is that I decided to scale my data with a function called robust scaler. Because if you use the normal one, you'll probably get a lot of errors in your data. One thing is that here I'm making emphasis that making sure that each feature has approximately the same scale can be crucial pre-processing step. When there's outliers, it is best practice to use scaler that is robust against outliers. And whenever I created my model, one thing that was really crucial was to add the class weight equaling balance, because at first I ran my model and it was predicting at 91%. But the thing is that whenever I did my my matrix, it was predicting most of the true values, so all the true positive values, and not much of the, well, pretty much nothing from the true negatives. So that was really important to put class weight as balance because of my imbalance classes.
So Mario, I remember you were using a different package too, right?
Yes, so I wanted to, so I'll let you know right after my models.
All right.
So with this model, so the way I interpreted this coefficients is that Bender 2 made a big impact on predicting 1, Bender and Bean and Death. And the top 3 that predicted that were able to predict 0 were the vibration of Bx and By and the Bender and the third Bender. So here I did my accuracy score for the model. And due to our classes being imbalanced, we couldn't rely on the model with the best classification accuracy. So here I predicted about 1,367 as 0 and 7,000 as 1. So here the sensitivity is a measure used to report how effective a test is in identifying an ESP with the running status. So the higher sensitivity is better. And same goes with the specificity, just with identifying the ESPs are warnings and downs. The higher specificity, the better. So you're just calculating both. So I wanted to do a classification report because looking at the confusion matrix, precision, recall, F1 score, and RC curve gave me more insight into the accuracy of the model. So in this case, the best models, well, overall the best models should have both high precision and recall values. However, there is often a trade-off between the two. Determining which matrix to optimize depends on the question being answered. In this case, the company wishes to find ESPs that may have a status of down warning. So for this case, recall should be really important. A missed down warning status is much more harmful to the company, which can cause downtime or a catastrophic event. In statistical terminology, this means that a false negative is more damaging than a false positive. Here's the frequency of the probability of ESP running. And here's my ROC curve for the model. So seeing the ROC curve can help you choose a threshold that balances sensitivity and specificity in a way that makes sense for a particular context. So choosing the classification threshold is a business decision. So here I just wanted to change the threshold to see how much difference it will make. So I decided to change it to 54 just to see what difference it will make. And it seems that it predicted, so my original matrix showed about 1,367 as true negatives, and see a big increase, about 100. So here's the new sensitivity and the specificity. So next I decided to do a random forest model just to see a difference between the two. Yes, question?
Already logistic regression has like threshold of 0.5, right? So you just use like 0.54?
Yeah, I said just to see what the difference would be. I was
Did
just
you try
curious.
like lower or high, like 0.2?
Yeah, so I decided to do higher, so it's 50, so I decided to change it to 54 to see what big difference it will make on on the true positives,
Okay.
and it definitely did a lot of
Didn't.
yeah. So that's when I decided to just do a different model and see what how it would perform better. I wanted to do a decision tree at first, but a decision tree, one of the big disadvantages is that you can easily overfit. So I decided to go stick with the random forest. I used the same columns, same train test to split, and I did my F1 score instead of the accuracy score, and it was a 79. The accuracy score did improve by 1 point. So here I see a big increase of 70 for sensitivity and 70 for specificity. I can't pronounce that right. Anyway, here's my classification report. As you can see, my recall for down and warning definitely increased from the previous one. Just show you really quickly here. So my original recall for down and warning was 63 and 68 overall. It definitely increased with this one going to 71 and 70. And what else increased? Probably my F1 score by 2 points. This model did a better job predicting down in the mornings. And just here seeing the ROC curve, it definitely increased the area under the curve by maybe 4 points, I believe. And just here I'm showing the importance of each label. It seems that X and Y are very important, and bender 1 and 3 made a big impact. So with that said, my next steps will be to oversample the minority class just to see how big difference it will make. And I tried to download a package, but it was a complete failure because my kernel kept crashing. But definitely that will be my next step for this project. And then I will use the cross validation to get the best recall rate from the logistic regression in random forest. For further analysis, I will use all 3 classes in the random forest and then compare that with the multi-class classification model. I would also try to use a survival analysis to analyze the time it will take for an ESP to go from warning to down. And I know that Python offers a really awesome package called Lifelines. And with all that, I would definitely like to ask any of you guys, what could you have done differently, or what I did wrong in my process here?
I think the oversample will improve the score. for
Yeah,
sure.
over the score. Yeah, I thought so as well. So that's definitely something I want to do.
Mhm.
I think the cross-validation
Cross-validation
will
also.
help you.
Okay.
I'm not sure if you spend time looking at additional features, to think about what are the features that will help you improve your downtime.
Okay.
Right now you spent a lot of time thinking about overall features of the model, but are there features specifically designed for downtime?
Okay.
What makes it?
What are the ones that make more impact for a downtime?
Correct. So what are those features? You got
Okay.
a little bit of feature engineering on that.
Okay.
And overall, the data does not look like it has a lot of missing values. Right? You already have a lot of values.
Mm-hmm.
I like your winning strategy. You think you're a little bit winning strategy. That's a good job. Well done.
So if you remove those outliers,
You think it will make a big impact?
maybe.
Okay. Even though it's part of the data set, will you remove them just to see?
Yeah, I mean, does that robust scaler help, like, that if there is an outlier in the testing data, will it predict the outliers properly, or what would happen? I don't know.
Yeah. So if I used a different scalar for the logistic regression, it'll definitely it definitely showed a difference of the coefficients here. So.
So do you have increased your accuracy on the downtime?
Did it increase?
Like that's your goal,
It was
right?
pretty much the same. Well, it was pretty much the same for the accuracy. I didn't really check. I didn't go into the classification.
No, I was
report.
asking, do you want to increase your accuracy more for the downtime? Then,
Yes,
Then I
yes.
think you can increase that threshold from 0.5 put to a little bit more and get more accuracy there and oversample perhaps.
Oversample.
I will vote perhaps.
Yeah, definitely.
So hyperparameter tuning,
Yeah,
cross-correlation
hyperparameter.
search, more features for town staff. You got a little bit of opportunity there to come try.
Okay.
But overall, I think good
Yeah,
work.
good.
Thank you.
So how many people here have T-Mobile phones?